we all care about the weather, and nobody wants to have the weather get the best of them.
One of the most devastating aspects of hurricanes is storm surge. You look at what Hurricane Helene just a few weeks ago did. It was a massive hurricane. It was 500 miles across. I can give you the best forecast in the world. I can give you plenty of lead time, but it's your decision to evacuate, and we can't control that.
And will we need a Category 6? Because these Category 5s keep getting bigger and bigger, but it's a storm we've never seen before. When are we getting to Category 6?
This is StarTalk. Neil deGrasse Tyson, your personal astrophysicist. Got with me Chuck Knight. Chucky, baby, how you doing?
Hey, Neil.
So, Chuck, today's topic is the weather.
Excellent. Yes.
That's supposed to be the safest thing to talk about with anyone, right?
No longer.
Oh, no, I guess not. Very good point.
No longer.
Very good point. But we know that it's extreme.
Yes.
And if we comb the earth to find who's the top weather person, that's going to be
Sam Champion, WABC News. He's amazing.
It's going to be, every local news has their person who they are certain is like the best weather forecaster there is. But we can go above them all because we're StarTalk and we have access.
Yes.
And we brought in the chief head honcho of NOAA, the National Oceanic and Atmospheric Administration, Dr. Richard Spinrad. Oh my gosh.
Wow.
Rick, how you doing, man?
Hey, I'm doing great, Neil. Chuck, delighted to be here. Thanks.
Let me get your full title straight here. The Undersecretary of Commerce for Oceans and Atmosphere. And that's a different title from being NOAA Administrator. Is that right?
Yeah, actually, my full title will probably take the full duration of this show, but it is the Undersecretary of Commerce for Oceans and Atmosphere and the Administrator of NOAA, the National Oceanic and Atmospheric Administration. So it's really two hats in this job.
And we're reminded that commerce, which is a huge branch of the U.S. government, cares about climate and weather, and because goods and services are delivered through the air, on the waters, over the land, and our relationship with climate is deeply impacted.
Yeah, like commerce and the melting ice that is causing passage through near Alaska. And it's a contested waters now because you have Russia who wants that water, and we, of course, and China, and it's all because it was ice. And nobody's looking at the point that it was ice.
What was once ice is now open waters.
It's now open water, right?
Yeah. That's so. Tell me a couple of things here. What is your relationship with the Navy? Because obviously they care about oceans as well.
Yeah, so that's a great question because I actually worked for the Navy for the first part of my professional career, and I was.
Is there any part of the government you don't work for?
Yeah, Congress. I have not worked for Congress yet, and that probably won't happen either. But Navy, I mean, obviously, Navy cares about oceans and climate and atmosphere, and it's not just how they operate their ships. They're going to be concerned about what the impacts of climate are going to be for their bases. You know, think about Norfolk, where we've got the Atlantic Fleet and sea level rise impacting the operations at the base there. It's an important element of naval operations. And
this
then
is Norfolk, Virginia,
Norfolk, Virginia, yeah, but I could say the same thing about just about anywhere the Navy operates. They do care about the shoreside facilities, but they also care about the ability to fly and carry out their missions. And obviously, I mean, one of the strongest components for Navy is understanding how the ocean changes. What are the dynamics of the ocean? How does that affect ships and submarines?
Right. And also, last I checked, there's several whole countries in the South Pacific where the average sea level is just only a few feet. The average elevation of the land is only a few feet above sea level. So if we start melting out glaciers, we'll lose entire countries, creating, what do they call it, climate refugees.
Exactly. And this is not some sort of theoretical thing that'll happen 1,000 years from now. The sea level rise rate that you're alluding to has increased dramatically. When I was a grad student, a few decades back, we would talk about sea level rise as being, say, 1 to 3 millimeters per year. In some places, it's doubled or tripled. And so consequently, some of these nations are actually going to be eliminated before the end of this century, they'll actually be underwater.
Right. Yeah.
So
Whole island
yeah,
nations that will disappear.
whole island nations. And I tell me, of course, everyone cares about the weather, although climate change has been politicized, as we all know recently. I'd like to remind people that NOAA was founded in the year 1970, and it was signed into law by a Republican president. So the politicization of climate, to me, feels like a very recent phenomenon, because clearly we all care about the weather, and nobody wants to have the weather get the best of them in any part of their life or job.
Yeah, I think a lot of the making it a political issue comes from trying to figure out whose fault this is. Who do we get to blame for this? The thing about NOAA is that our mission is very much looking to the future. We're about predictions and projections, and so for us, it's less about, hey, who caused this problem, and more about how well can we predict what the change is going to be in the future. Right. We talk about sea level rise.
And that's what people hold you to, because they're trying to make decisions based on your predictions.
Exactly. However, you have a moving goalpost at all times, Rick, because quite frankly, what happens is these projections are modeled on what we have now. Okay. But the variable is, do we increase the amount of fossil fuel that we're burning? Because, that's really the issue. So as you have fossil fuel burning coming online, that changes everything that you guys said was going to happen. For instance, the predictions that were made previous to now, basically everybody's like, oh, yeah, well, they're all wrong. But first they were saying they're going to be wrong because it's not going to happen. Now they're saying wrong because it's happening much quicker.
Yeah.
And in fact, the models would normally have a future expectation for a rate of CO2 increase, or a rate of anything. Isn't that right, Rick?
Yeah, that's right. And this is what climate scientists would call the assumption of stationarity. That is to say that things now are what they're going to be in the future. And it's not. And that's the whole point is, so how do you take the models that you were talking about, Neil, and initialize them, put the data in up front to start the model? What assumptions do you make about how those conditions are going to change in a year, in 10 years, in 20 years? That's the challenge we have in front of us. But we're getting really good at improving the skill on those models.
Now, Rick, has your scope been, I'm wondering, I think when NOAA was founded, by the way, I did a deep dive into this. Hardly anyone, certainly not even geologists or biologists, had ever combined ocean and air in the same sort of conversation. There were atmospheric scientists, there were oceanic scientists, and the full system, the full organic system of all these interplaying parts, it seemed to me only came of age a little later, when computer models started having something to say about it. And so now what I pose to you is, now what's under NOAA purview is also space weather, like what the sun is doing. So these look like land grabs to me, or spacecraft. You started out with just the ocean in there. Now you want like the solar system.
The universe. We're going for the universe.
Going for it.
Yeah, Neil, you're exactly right. And it is an Earth system. And the best place to see that is in how hurricanes form and grow and move. You can't predict that without a good understanding of the ocean and the atmosphere. And, the best example on that one was Hurricane Katrina, which, as you may remember, intensified really quickly before it made landfall around New Orleans. And we now, looking back, know we could have predicted that better if we'd had better data from the ocean in the Gulf of Mexico.
In other words, had Katrina happened today, you would have predicted it better than we were able to do back in 2005.
Yeah, certainly the what we call the rapid intensification of the hurricane as it made landfall. And that's because we would look at the whole ocean, not just the surface of the ocean, to put the data into the models.
Yeah, but you guys, you're being humble, because you're not tooting your own horn about this last huge storm that we just experienced, where the rapid intensification was predicted and did happen indeed, due primarily to the amount of moisture that was being held in the landmass where the storm was going to traverse. So, you should say, yeah, we didn't do it back in 2005, but take this, bitches. We did it now. I'm sorry.
I don't think he speaks that way, Chuck.
I don't know.
I love the way you said that, though, Chuck, because you got it right. I mean, that was the
So Rick, catch us up on this thing with land water and how that is not neutral as a forcing factor on a hurricane that makes landfall. What I understood, there was a recent hurricane that saturated the landscape, the land. And so now when a hurricane makes landfall, there is sort of latent heat available to it from the water that is in the saturated ground. Oh, because normally a hurricane would weaken as it goes over the land, right?
Yeah, it's all about temperatures, right? And so we know the temperatures of the ocean, in this case, the Gulf of Mexico, are going up. We know the temperatures in the atmosphere are going up, which means that those storms can hold more water. And so think about it. We had Hurricane Harvey that hit Houston, and it dropped 5 feet of rain. When I was a kid, we didn't talk about feet of rain from a hurricane. And so now you look at what Hurricane Helene just a few weeks ago did, especially in western North Carolina, and the damage was water. You're absolutely right. Most people think hurricanes, it's about winds.
Wind.
In that case, it was water.
But in terms of the forcing function on the hurricane itself, that water that's sort of still had rendered land masses soaked. Are you saying that does not continue to play into the other than the water's got nowhere else to go? I guess you just get
Well, that's basically it. I think it's a combination. If you've got soaked terrain from previous precipitation prior to the hurricane coming in, and that hurricane's got more moisture than it would have before. Helene was also huge. It was a massive hurricane. It was 500 miles across. And that's significantly larger than most hurricanes. So large hurricane, warm waters, so more moisture available. The ground was already pretty wet, and now you're just dumping buckets onto a wet sponge.
Right.
So it's going to cause a lot of flooding.
Why do I have in my notes that you also care about the bottom of the ocean? Like, what does that do for you?
Well, there's a hole in the bottom of the ocean.
No, there's a plug. You know what?
Oh, that's right.
Yeah. The bottom of the ocean is important because without a bottom of the ocean, we wouldn't have an ocean, I guess.
Oh, okay.
More important, so the topography of the ocean is going to help drive how the currents, especially in coastal environments, where the water goes, how it flows. It's going to impact things like accentuated tides in areas where you've got extreme changes in topography. So why is this important, especially in the context of a hurricane? Probably one of the biggest problems, one of the most devastating aspects of hurricanes is storm surge. What happens to the water, the ocean water, when it gets close to the shore? If the topography is just right, you can actually funnel that storm surge and you can end up with 12 to 15 feet. That's what they got in Tampa Bay when Hurricane Milton hit.
Yeah, and Hurricane Sandy hit New York. I mean, I think it was Tropical Storm Sandy at the point it hit New York, but that storm surge is what took us out.
We actually call it Superstorm Sandy because it was both a tropical cyclone and then there was a nor'easter component to it as well. Right. So it was kind of like the worst of all factors combined. And you're right, storm surge. Yeah, I grew up in New York and my mom was living in an apartment that got flooded as a result of Superstorm Sandy. And we did not, that's interesting. That was, 12 years ago? We didn't have the forecast down pat yet.
Having the front row seat to Neil's life over the years and also being a parent myself, I absolutely love that quote. As parents, there's no greater gift we can give to our kids than the freedom of curiosity and an eagerness to always be learning. And that's why we here at StarTalk are honored to have KiwiCo supporting today's episode. KiwiCo is on a mission to spur innovation and creativity within our kids, delivering monthly STEAM learning packages consisting of experiments, hands-on engineering projects, models, games, and more. The recently launched KiwiCo Clubs offer a variety of monthly lines that cater to all ages and interests. KiwiCo Labs is for the aspiring engineer and scientist. KiwiCo Studio focuses on art and design, and they've even got KiwiCo Sprout for the younger kiddos you want to encourage to fall in love with STEAM. Each project builds on the skills that they are learning, and they are rigorously kid-tested, ensuring that your kids are not only having fun, but also developing new skills along the way. So, this holiday season, we encourage you to give the gift of education to all the young budding scientists in your lives, unlocking a lifetime of curiosity and creativity and adventure. Head to the link on the screen here or use code StarTalk at checkout for 50% off your first monthly club crate. That's kiwico.com/StarTalk for 50% off your first monthly club crate. Okay, let's get back to the show.
So when did you start reaching out and caring about what the sun does?
Well, we've always had that as part of our mission. I think it's fair to say that.
I mean, obviously the sun has a luminosity and an energy, but at the next level, the sun cycles and there's solar storms. And so it's not just that there's a star there delivering energy to your model. There are these fluctuations in the energy to the model that now you guys seem to care about.
Yeah, so the sun is a pretty dynamic object, and it goes through these cycles, right? And we're actually in the middle of one of these 11-year cycles. It started last year. And one of the really interesting aspects of that is that the sun can occasionally actually send out these huge coronal mass ejections, which are these charged gases, the plasmas that get ejected from the surface of the sun at a speed of about 1 to 2 million miles per hour. They are, on the sort of positive side, the factors that create the beautiful northern lights, the aurora borealis. But a little bit more insidiously, they also interact with navigation systems. They interact with electrical grids. They can affect power grids. They can affect communication systems. And so, in fact, the storm that erupted in last May of 2024.
Solar storm.
The solar storm was a category, what we call G5, geomagnetic storm 5, highest ranked storm, one of the most severe that we've seen in decades. But you didn't hear about it much. Well, I know you did, Neil, but a lot of people didn't hear about it. And that's because we knew it was coming. And in years past, we might not have known it was coming. And so we could make changes. What kind of changes? Airplanes could change their routes in order to avoid the impact of the solar storm on their GPS systems.
Can you see the actual discharge as it makes its way here?
That is so cool. Yes, you can. And in fact, we have just launched in June of 2024, we launched a new satellite. It's a weather satellite. It's the one that you would use when you turn on TV and they show you the full disk of what the weather patterns are on the East Coast or West Coast. But this one has a compact coronagraph.
Oh,
and
nice.
That is the tool.
I'm sorry. You guys lost me. Neil said, "Oh, nice." You said compact coronagraph, like like I say, my glasses case. It's just like my glasses case, and I'm like, okay, what is a compact coronagraph?
So I got this. So one of the great inventions of the recent century has been the ability to create an image of the sun in a telescope as though, with a set of optics, as though the sun had just been eclipsed by the moon.
Oh.
And when the sun gets eclipsed by the moon, all the bright stuff is blotted out and you see the edge and you see explosions on the edge.
Right.
You remember when we saw the eclipse, this recent eclipse, when we were stationed up in Vermont, you saw these, along the edge, there were these little sort of prominences sticking out. So imagine being able to do that at will, right? Rather than waiting around for an eclipse.
Interesting.
And so now, Rick, you say you put one of these in orbit. That's cool.
Yeah, we actually have that one in orbit. There is another sensor on the Discover satellite, which is at the L1, the Lagrange 1 point.
The Earth-Sun Lagrange?
Yes, exactly.
Okay. Now, Chuck, don't we have a Lagrange explainer?
We do. For those of you who want to really go a deep dive on Lagrange points, we go all through all L1, 2, 3, 4, and it's really incredible.
And 5. Can't leave out L5.
And 5. Clearly, I was only paying attention for 4.
5's important because we're
5's a really good one.
5's a good one.
5 here in a few years.
All Lagrange points are not made equal, right?
But if you want to see how you can find perfect equilibrium in the solar system, to me, that's what the Lagrange point represents.
Exactly. So it depends on which two bodies are around which you're describing the Lagrange points. So Rick, this is the Earth-Sun Lagrange points. Is that correct?
Yeah, and as you can well describe by having multiple views of the sun from different angles, that is to say, in Earth orbit and then at L1 and at L5, we can look at basically the whole three-dimensional character of the sun, because not all of these coronal mass ejections are necessarily aimed at us. So we care about them all, but at NOAA, we care mostly about the ones that are going to be aimed at us. And again, to do the math, these things travel in about 1 to 2 million miles per hour. Sun's 93 million miles away. So it's a 3 to 4 day transit that we can give people enough lead time to make preparations for a major geomagnetic storm.
So we can imagine a future where we have a colony on the moon or Mars, where neither of those objects have shielding from this kind of radiation in the way we pretty much do here on Earth with our atmosphere and our ozone layer, but they don't. So presumably they would be deeply connected into your capacity to predict these storms, because then everyone would know to run underground or run behind shelters, this sort of thing.
So can I ask, okay, this might be a silly question, but I'm just asking. So with all your equipment, because NOAA is really a space organization, I mean, you're looking back at Earth, but all your stuff's up in the space.
No, they got buoys and stuff.
That's true. I take it back. Okay, you're absolutely right. But when you talk about these ejections, do you move that stuff, or is that stuff just hardened, or what do you? Because I mean, radiations has got to be like the most damaging thing for equipment, right?
Yeah, you're not going to be able to move this. I mean, this is immense amounts of energy. But what you can do is it's really similar to our discussion on hurricanes. We're not going to be able to move hurricanes, in spite of what some people may think, but we can make the predictions work, and we can tell people this one's bearing down here on Tampa, plus or minus 20 miles, and you got 2 days to evacuate. Same thing with space weather. If we get the picture, especially if we've got multiple views, we can say this is going to hit pretty hard in the northern part of Quebec or in Asia, and therefore folks can make adjustments. They have 3 days. They can power down their grids, their electrical grids. They can revector aircraft, so they're not going to be affected for navigation purposes.
Chuck asked about the satellites that are already in orbit. They certainly have a susceptibility to this. You can't just say, hey, bank a left or hover over Africa until it's clear over Asia, right? You can't do that.
You can't. We can shield some of these to a certain extent, but what we can do is, again, if we know it's coming, we can make accommodations with regard to power or use another satellite to cover for the one that might be most vulnerable.
The sacrifice satellite.
Yeah, no, we don't do that. We don't put them up for sacrifice.
Right, so there's something called unexpected events. Now, I foresee the day where no event is unexpected. And so no one is taken by surprise. Where are we now with regard to NOAA's modeling and other agencies' modeling and things just happening, taking everyone by surprise?
There's a really interesting aspect to your question, Neil, because there's a famous story in meteorology. It's called Isaac Storm. In fact, Eric Larson wrote a great book on Isaac Storm, and it was a hurricane that hit Galveston in the year 1900. For the folks in Galveston in 1900, that storm was an unexpected storm. They didn't expect it to hit. Now, obviously, there's never going to be another Isaac Storm. We've improved that. There are things, though, that happen on much shorter timescales. And so I would say they may not be unexpected, like tornadoes, but the time that we're able to give people to react to them and warn them is shorter. So right now for tornadoes, we're looking at an average lead time on most tornadoes of about 12 minutes.
Whoa.
About 50 years ago, the lead time on tornadoes was minus 5 minutes.
Okay, that doesn't even make any sense.
Right.
I'm just saying, when the tornado's over, I already know there was a tornado.
That's right. That's right. Yeah, there is something wrong with that picture.
Wait. Just to clarify, you're not talking about the prediction of the existence of a tornado. You're talking about the path a tornado will take once it forms?
Yeah, the path it's going to take and how intense it's going to be.
Gotcha.
Wow.
And because there are, like with hurricanes, tornadoes have classifications by intensity. We have the extended Fujita scale for tornadoes, 1 through 5. And it's the same kind of thing. So right now we can say we think this tornado or this aggregation of tornadoes is going to take this path, and it's probably going to be an EF2, and it's probably going to hit over here in 15 minutes.
By the way, 12 minutes, 15 minutes is enough time to get out of the way of a tornado.
Or to go
or underground.
Yeah, underground. Right.
Yeah. So that's incredible.
How do you feel? I mean, do we have deep resonant emotions when, for example, you go to see a movie that, Storm Chasers movie,
Yeah.
Twisters. Twisters. How do you let's commiserate together here now? How do you feel when you see these films? How much effort do they call you and say, "Help us get this right," or they just make stuff up?
And is it true that in a tornado I can actually call a cow as it comes by and it goes and then disappears?
Of course, Chuck. That's a stupid question. Everybody knows
that. We are not using bovine sensors in tornadoes for our forecast systems yet. So,
because a cow could just totally hook you up on that. Right. What is if you mind if I ask, what is NOAA's annual budget?
It's just under $7 billion.
Would you say that NOAA's effort saves people and lives on a level far beyond the value of that budget?
Well, I mean, we talk about
the answer is yes, Rick. You're the head of the organization. For Christ's sake, man.
Neil, the answer is yes. Right.
Thank you, Rick.
We talk about lives and livelihoods and lifestyle. So property and lives, but certainly lives. And the only reason why I hedge is because I can give you the best forecast in the world. I can give you plenty of lead time, but it's your decision to evacuate. It's your decision to take action. And we can't control that. So we like to think that two things. One, the quality of our forecast is getting better. And the second is the trust by the public in that forecast and the on-screen meteorologists and emergency managers is high enough so that when we say, you better evacuate, the storm is coming your way, people actually take that action. But there's no question. I mean, I talked to you about the Isaac storm in Galveston in the year 1900. And I think the number was something like 10,000 lives were lost in that storm.
Wow.
Oh my
That's not ever going to happen again in this country, ever. And that's because of the quality of the forecast and our ability to have the trust of people to make these decisions. So, yeah, absolutely, we're saving lives.
And you also affect forecasts for fisheries, right? And other sort of coastal management of marine food. Is that a fair?
Yeah, so we do marine forecasts as part of what the Weather Service does. And we also have responsibility for managing marine fisheries, which means we're the ones who do the stock assessments of how many fish are out there, how healthy are the fish, how healthy are the populations, and establish regulations for how to sustainably fish for these fish and maintain a strong seafood economy. Again, we're part of the Department of Commerce, so it's an important economic consideration.
So with respect to what you just said, what's your relationship with other countries? I know we're a national organization, but do you have international affiliations like for the typhoon that's raging in Taiwan right now? Or when it comes to sustainability of food supply, like working with China, who just doesn't give a damn. So, but what's your role there?
We care about our coastline and our oceanic property line, if you will. But if you're studying the entire Earth with regard to climate, do you share your data with other countries, and are they responsive? And what's your relationship? Yeah.
Yeah, we absolutely can't do our job without strong international collaboration. And that takes a couple of different forms. There are worldwide organizations. There's the World Meteorological Organization, of which we are a member. And in fact, the head of our National Weather Service is the U.S. representative to the WMO. And it's these organizations that establish policies with regard to data. And yeah, all of our NOAA data is publicly available. And we use that as, if you will, a lever to say to other nations, hey, we're giving you ours. Why don't you give us yours as well? So there's a lot of collaboration for data. And they recognize they need our data to improve their forecasts. We need their data to improve our forecasts. And when you start talking about fisheries, yeah, there's a lot of international agreements because a lot of the fish are in open ocean waters and there have to be agreements. And,
right.
and the agreements are not just about, hey, how much fish can we take sustainably? That is to say, to allow the population of the fish to stay healthy, but also to try to be the protectors of those fisheries by enforcing laws against illegal, unreported, and unregulated fisheries, what we call IUU fishing. So that requires a lot of international cooperation because you know what? It's a big, big ocean.
It's not the same thing, but it's similar in some ways. The Artemis Accord, which has recently been signed by upwards of 30 countries or so, it's a new agreement about conduct in space and space exploration signed by spacefaring nations. It's an active accord that's going on right now. And so, for example, if you send a rover to the moon or Mars and you learn something about it, you would share that with other countries so that they send a rover, they don't have to make the same mistakes you did, or that you can collaborate. So it's interesting how the internationality of what you do certainly would contain taproots for doing things cooperatively in space.
And I think there's a lot of commonality there. And the thought that was going through my mind as you were talking about the Artemis Accords, Neil, is that we need to have similar kind of agreements for making observations in the ocean. There's no one nation that can cover all of the ocean. And so we have a major program. It's called Argo. And it's basically these robots that go throughout the ocean and they go up and down and all over and they drift around. And we, by international agreement, have said, let's all agree to what these robots, these floats should look like. Let's all build them to these specs. Let's put all of these things out there. So there's about 4,000 or 5,000 of these out there now, and they've been floating around for decades. And let's all share the data in a common data repository.
These are those buoys that I was thinking about. Is that right?
These actually dive down, so they don't spend a lot of time at the surface. They float around and then they ascend to about 1,000 or 2,000 meters depth. They collect temperature, salinity, other kind of variables are measured. They'll drift for about 10 days out of 2,000 meters, then come back to the surface, transmit their data through satellite communications to a central repository, and then dive back down again and start, rinse and repeat, basically.
That's badass. I just have to say.
That is. Yeah. Now, there are some nations, though, they probably got a backdoor like, if you find oil, don't tell anybody else.
Hey, StarTalk fans. I don't know if you know this, but the audio version of the podcast actually posts a week in advance of the video version. And you can get that in Spotify and Apple Podcast and most other podcast outlets that are out there. Multiple ways to ingest all that is cosmic on StarTalk.
Let's take up this subject of climate change for the moment. So we know, is the fraction a third? So for every X amount of CO2 that goes into the atmosphere, does the ocean uptake about a third of that or some fraction of it?
Yeah. There's a variety of estimates, but that's pretty close, maybe even closer to a half, but definitely a large percentage.
Okay, so that means the dissolved CO2 in the ocean is in some form of partial pressure equilibrium with the CO2 in the air. So if we were to stop CO2 production or even introduce CO2 scrubbers in the atmosphere, we will do this, but then there's less CO2 pressing down on the ocean, and the ocean says, I have to make this make equilibrium out of this, and it'll start releasing.
And it gives it up to the atmosphere.
Gives it up to the atmosphere. So is it true that we would not see the immediate effects for quite some time, perhaps decades, even if we stopped all fossil fuel burning today?
The short answer to your question, Neil, is yes. People talk about the flywheel in the carbon cycle. You could stop the introduction. Interesting, you raised the question of actually actively removing carbon dioxide from the atmosphere, which would accelerate the diminishment of excess carbon dioxide in the atmosphere. But it would still be, yeah, you're right, decades before we would see the ocean responding in kind. Part of the problem with the dynamic you described is that the increased carbon dioxide dissolution in the ocean manifests as ocean acidification.
Right.
The pH of the ocean.
Whole other thing going on.
Yeah.
Okay.
Yeah.
Of course.
Yeah. And so in that case, it's not simply a matter of, it's not like opening up a bottle of Coca-Cola and having all the CO2 go back out of the liquid into the atmosphere. A lot of this CO2 has become part of the carbon cycle within the atmosphere, including with a decrease in pH and increased acidification.
And that's where you see the complete bleaching of coral reefs and the death of these coral reefs, which, by the way, are their entire ecosystems in themselves.
Yeah.
That's part of it. In fact, a major contribution to coral bleaching is actually the temperature. It's the warming of the water. But because of the chemical makeup of most corals, the increased acidification is very corrosive then to the corals.
So when people talk about terraforming Mars and moving there,
I'm sorry, that was just an excellent segue.
As Earth Plan B, my rebuttal to that, it's not a rebuttal, my comment on it is, if we have the power of geoengineering to turn Mars into Earth, then we have the power of geoengineering to turn Earth back into Earth. You wouldn't need Mars to do that. And so that's kind of how I view that. So Rick, this past hurricane season, is it just my imagination, or were there more Category 5s kicking in than usual? And if so, is that the new normal? And what is the new normal? Right now, today, we're recording this in October. It's like 75 degrees outside. When it says unseasonably warm temperatures today, will that soon become seasonably warm? Does unseasonable become seasonable because that's the new normal?
And will we need a Category 6? Because these Category 5s keep getting bigger and bigger, and they keep saying Category 5, but it's a storm we've never seen before. When are we getting to Category 6?
Chuck, stop poking the bear. That's what you're doing.
I love that question, Chuck, and I will get to it in a minute. But what I do want to say is, I keep thinking about the New York Times columnist Tom Friedman, who said it's not global warming, it's global weirding. And, and if you think about it, Neil, we don't talk global warming anymore. We talk climate change. And that's because it manifests in so many, many different ways. And fundamentally, what we're doing is we're putting more energy into the system. Because of the greenhouse effect, there's more energy coming into the system. So your question about what's going to be seasonable or not seasonable, what do the storms look like? Things are going to be different. This year, for example, we predicted an above normal hurricane season, and it's turning out it is above normal by certain measures. Is that going to become the new normal? Well, I think just logic suggests that we can probably see a lot more hurricane activity in the future in terms of the intensity of the storms, how much water they have with them, that sort of thing, which gets to Chuck's comment. And that is, my take is it's not about do we need another category, a Category 6 in the Saffir-Simpson scale.
Chuck wants you to name it after him. A Chuck hurricane is a Category 6 hurricane.
Well, there's something wrong with calling something a nice hurricane. That's the
problem. We'll call it not so nice.
Not so nice.
No, you leave out his last name. Just call it Chuck Hurricane.
The Chuck Hurricane. What we really need in that regard is to expand the focus, because the Saffir-Simpson scale is really a measure of wind, right? How strong are the winds? And you see that every time. Hey, the winds have just gotten to 138 miles an hour, so now it's a Cat 4, that kind of thing. But when you look at what these hurricanes are doing, we're looking at impacts of storm surge. I talked about the volumes of water from hurricanes like Harvey years ago. We need people to understand that we should be looking at more than just what the peak wind is. Because you could have a Cat 5 with really strong 170 mile an hour winds, but it may not have the impact that a Cat 3 has with a large volume of water like Hurricane Helene had. So we need to find a way for people to understand the full measure of what the hurricanes are, what they look like, and what their impact's going to be.
And let me toot your horn for a moment here. In the 1989 sequel to Back to the Future, titled Back to the Future Part 2, they went into the future, the year 2015. And so we're watching this movie in 1989, and they are imagining the year 2015. And there's a point where Marty and Doc get out of the car, and Doc puts up an umbrella, and Marty says, "What are you doing?" He says, "Oh, this is the future. Weather forecasting is now, we know the exact minute it's going to start to rain. And right in that instant, it starts to rain. And then it stops. Ready, stops. And then it stops, and he puts the umbrella away. We're not exactly there, but of course, on our smartphones, it'll show you when the rain is going to begin, where you are, and where it's going to end. That's what I'm saying.
That's true. I never even thought of that, but it gives you the time of day. It's like 3 p.m. starts. Yeah.
And your spot. And it tells you how much and how intense. And Chuck, when we were growing up, it was like all you really want to know, what might it rain tomorrow because you have a picnic.
Maybe.
And then they give you a 50% chance, which means they know absolutely nothing.
Right. Your grandmother knew more. My bursitis is acting up. My shoulder. I'm telling you, baby, it's going to rain tomorrow. My shoulder.
How do you, for all you know, Noah's got grandmas in the back room.
Yeah, right.
Ethel, how's your knee? I tell you, it's going to rain.
And Ethel predicts the hurricanes.
Exactly.
Well, it's interesting because I was going to say, Neil, that, I do have a couple of apps on my phone, in fact, and I use it for just that. Okay, should we have that picnic now or should we wait an hour? That kind of thing. And that's less about the prediction and more about the observations. And so the radars that we've got, the satellites have got so much resolution right now that you can start doing that. You can, within an hour or two, you can say, hey, this storm, I use it all the time when I'm walking my dog. I'm saying, all right, should I do it now or should I wait an hour?
So you're saying that's because we have real-time observation of what's happening.
Exactly.
Gotcha.
Yeah. And we can, and tornadoes are a really good example. We've gotten really good at observing tornadoes using some of the new sophisticated applications. We use something called dual polarization on our weather radars, which is, in the old radars, it was basically just send out a signal and see what comes back. And now we can start manipulating the signal, looking at the polarization of the signal to determine, is that rain? Is it sleet? Is it snow? And get such good resolution that we can say, yeah, it's sleet, but we know the temperature 2 miles away is warmer, and we can see how fast it's coming. So in an hour, it's going to be rain over here.
Wow.
We're not going to have sleet.
That's okay.
So cool, man.
We actually fly through the hurricanes, and we've been doing that for quite a while. We have two, actually more than that. We have at least 3 airplanes that we use to fly through or over the hurricanes.
That's the right stuff right there. Want to talk about modern right stuff.
Man, and I've done that once. I did it once with our team.
Who you got to piss off to get that job?
these
no, but in all fairness, Rick, if I ran some of the math on this. If you're standing there on stationary Earth and a 170 mile an hour wind is coming by you, that's going to tumble buses and trucks, and the cow, of course, will fly by. However, an airplane in open air flies 500, 600 miles an hour, way faster than the air in a hurricane. So is it not as dangerous for an airplane as you might otherwise think?
Yeah, I'm going to be the first to tell you, it is a dangerous thing to do, but our crews are real aces. They are amazing professionals. And the equipment that we fly, we actually fly 50-year-old airplanes, but we're scheduled to buy some brand new ones here soon. And we fly Navy P-3s, the same airplanes that the Navy used to use to find submarines. And here's the kicker, that we fly them high enough through the hurricane that, when you go through the eye wall, the hurricane, where there's extraordinary vertical wind currents, you're going to go through several thousand feet of elevation change. If you did that on a commercial flight to Cleveland, you'd have a real problem and you'd be sending a complaint to the airline.
Going to be a lot of vouchers given out at the end of that flight.
And we do it repeatedly. We'll do like a figure 4 pattern through the hurricane 2 or 3 times. And then the other really cool thing, though, is we don't just fly those aircraft through the hurricanes at, say, 8,000, 10,000 feet. We also drop drones from the airplanes so that those drones can then fly at the lower altitudes and get all the data we need. So, when you talked about...
You're not just joyriding, you're getting data at every turn.
Oh, we're getting data up the wazoo, real time. It's going back to the National Hurricane Center. They are assimilating those data into the predictive models. And because of those flights, the track and intensity forecasts have improved by 10, 15, 20%. So that real-time message to the guy on the beach who says, I don't know if I should evacuate or not, has gotten so much better. Look at the tracks from Hurricane Milton. You saw that. 2 or 3 days out, we were saying it's going to hit Tampa St. Pete.
Yes,
and we were spot on.
Tight.
Yep.
They were totally tight. So, Rick, as weather phenomena around the world, even if it's just simply higher temperatures than ever before, whatever is the phenomenon that's stretching the limits of what might have been models that were comfortably contained within certain parameters, every time there's an unprecedented event that you didn't predict, what do you have to do with your models? What's the next step here?
Yeah, that's a great question, especially if you kind of extend it and say, how does something like AI or machine learning, artificial intelligence and machine learning fit in here? And these extraordinary events. And I think some of the heat waves we've seen, some of the droughts we've seen are examples. They end up providing an incredible volume of new data. And our artificial intelligence applications depend critically on what we call training data. So the data from what has happened in the past being used as training for the models of the future. So I would argue when we don't fully characterize a particular event with our forecasts, but we are able to collect all the data from that event, we are by definition improving our ability to use AI techniques, machine learning techniques.
Except by definition, your AI that's mining the data will not have data that it has never seen, that is yet to see.
Which is the argument for making sure we fully measure and characterize these extreme events. And so a lot of our investment at NOAA is building the systems that provide much more intense, higher temporal resolution in the data for things like extreme precipitation. One of the main things we're trying to do right now.
Just to clarify, temporal resolution, you can think of spatial resolution, how much detail do you have from A to B to C in location, but temporal resolution would be what's happening this hour, this minute, this second. And so it's the resolution over time, in case people were wondering.
Everybody wants to know what's happening in their neighborhood, right? And
right.
A lot of the kind of data, historic data. Exactly.
Right.
And if all I can tell you is, we've got data from York County for the last month, that's not good enough. And so what we're trying to do is really increase our ability to collect data, which means having volunteer observation programs. It means using sophisticated new technologies. I talked about our radars. We have 122 radars around the country. And these radars are many decades old. And there's some new technologies out there, things like phased array radar that we might be able to use to get the sort of higher resolution observations.
It sounds to me like NOAA might need a bigger budget. I'm just saying, we're flying around in 50-year-old prop planes. Okay, we got sensors that are old and
20 years old.
20 years old. Like, we need, come on, Congress, let's make it rain on NOAA.
20 years ago, there were no smartphones and YouTube didn't exist. So, in terms of where we are.
We do. I mean, if you look at the full NOAA mission, it's really pretty incredible. We've been talking mostly about weather here, space weather, atmospheric weather, but we also make all the nautical charts. If you're a boater and you want the chart, and you want to know how deep the water is and where are the shallow areas, we do that. We manage marine protected areas. We haven't even talked about our fisheries management. And you know what it costs every American for all of these services? It costs 6 cents per day.
Here's what we need. We need Sarah McLaughlin
To sing a song.
To sing the song, and then we could tell people for only 6 cents a day, we can support NOAA in a way that
Sarah McLachlan.
nautical, right?
They need a Sarah McLachlan worthy song.
Yes, exactly.
Everybody will just flow. Yeah.
Right, just let it flow from nautical charts to Aurora Borealis. NOAA is in your life, and for only 8 cents a day, which is 2 more pennies than what you're paying now.
Well, Rick, thanks for making time for us.
Thank you.
We last crossed paths back when we were trying to figure out how to see this last eclipse, and a lot of folks saw it. Some were clouded out, but eclipses can happen again. And we have things called airplanes that could take you to where the next eclipse is. You don't have to wait for it to come to your farm again. But I just want to say it's been a delight having you on here. And do you think you would? Are you likely to be replaced? I mean, are you a political appointee?
I am a political appointee, and so
Okay.
I serve with the pleasure of the president. So,
I mean, I think you're the right guy. Several people, such as there have been several NASA administrators that went through multiple presidents and multiple parties.
Yeah.
So that was a reminder to me or to us all that certain activities of the nation transcend politics and transcend the political leadership because they're surfing on science that is the underpinning of it all.
I know more about science than all the scientists.
Yeah.
All right, so we got to go. So give my regards to your whole agency.
This has been a blast. And Chuck, it has been a pleasure. Thank you so much.
Rick, thanks for being on StarTalk. We loved everything you told us, and it gives us great hope for the future. Indeed. Chuck, always good to have you, man.
It is always a pleasure.
All right, Neil deGrasse Tyson here, your personal astrophysicist. As always, I bid you to keep looking up. This is StarTalk Sports Edition, and today's episode is all about tech in sports. And let's, in fact, title it Tech Rules. And who do I have with me? My co-host, Gary O'Reilly. Gary.
Hey, Neil.
God, I love having you, Gary, and we love your accent straight from the UK. But that's not why we have you. It's because you're ex-pro footballer. Soccer player, I think we call it over here. So great to have you, your perspective. And you spent time as an announcer. So that was also good. Very, very cool. I assume you were announcing soccer.
Yes.
Not something else.
No, they wouldn't let me loose on the royal family, so I just had to stick with soccer. Royal
family need full-time announcers for what they're up to. And Chuck, always good to have you, man.
Always good to be here.
And your body of knowledge of sports always impresses me. I don't want to say surprises because that meant I had low expectations.
You meant surprise.
You have a fluency that I don't find with many comedians. I just want to thank you for lending that to this show.
Oh, yeah, sure.
Very excellent. So we could opine on this subject, but really what we really need is an expert. That's what StarTalk is all about.
Subject expert.
Subject expert. And we've got Professor Rayvon Fouché. Rayvon, welcome to StarTalk.
Thanks so much for having me.
Excellent. You are a professor in the School of Interdisciplinary Studies in Purdue University. That's the Boilermakers, right?
It is.
And you guys in Indiana, if I remember correctly, you don't have daylight savings time there. Is that still the case?
I think some parts have daylight saving times, but I believe other parts don't. So we're splitting the difference.
Okay. I don't think it's supposed to work that way, but that's
we're embracing the interpretive flexibility of time here.
So you are author of the perfectly titled book for this episode, The Game Changer.
Yes.
Techno-scientific revolution in sports.
All right.
Okay. And also Black inventors in the age of segregation.
Whoa. Whoa, we got to bring you back for that.
So you mean up until last year?
Is that what that is?
Okay.
No.
That's good, Chuck. You're a bit ahead of me. I'm not sure.
You're not even sure that's happened yet.
Yeah.
So you have a PhD in science and technology from Cornell. It's great to have you on here. So thanks for participating in our Game Changer series, which is sort of a sub-series within our sports edition. So interdisciplinary studies, that feels kind of sort of wishy-washy. So where does the science fit into that?
Wow, man, why you got to do that to my man's?
I'm just asking. Interdisciplinary.
How you going to do that to his concentration? Interdisciplinary. I mean, I'm just going to say that's very, very weak in women.
That is not what I said. I said I'm trying to understand it. I'm asking questions. Okay.
All right.
So take me there. What happens in interdisciplinary studies?
So,
I'm impressed.
You should be the biggest champion of interdisciplinary studies. It's just bringing together multiple different disciplinary perspectives and asking questions that are bigger and larger than one disciplinary space.
Oh, snap. So it's like the cosmic perspective for science itself.
No, it's...
Oh, shoot.
Thanks, Chuck.
Okay, that was good, but I wouldn't give it an oh snap. I mean, I would save the oh snap for, and there's the Z snap, you gotta, but anyhow.
Guys, just wait there. I'm going to get the snapometer. Right, it's just behind me here. I'll bring it in and we can, where it seems it registers on the scale.
So how far back would you say technology has impacted sports? I can tell you, I used to row and I was only told about this. I never read it because I didn't want to believe it. But that there was a day when rowers, before they had the seat that rolled, okay, the sliding seat, they would grease your butt and you would slide back and forth on a polished surface when you rowed. And I'm thinking, damn, but at that time, would that have been considered high tech? Friction, low friction, grease, butt sliding, increasing power to the stroke. At what point do we say sports has been touched by technology?
My perspective is technology influences sport from the beginning. So roughly 3000 BC, they have instances of wrestling, Greco-Roman wrestling, bodies and arms. And the moment, I would say, you potentially move past that moment of people using their bodies and arms, you have a ball, a piece of equipment of any kind, it becomes technological. And all of a sudden, that changes the nature of sport. All of a sudden, you go from using your own body to playing with something else that can be manipulated by an athlete, a competitor. Technology enters the game.
So it's a tool. It could be material science or anything else.
Yes. And
okay. So when they started oiling themselves with olive oil, that was a technological advancement for Greco-Roman wrestling.
Exactly, because olive oil comes in many different forms. It can be Spanish, Italian, and it depends on what part of the world you're from. Maybe Italian oil is better than Spanish oil. I don't know.
But all right, but when we move forward in time, there's certain sports that feel distinctly backwards. I think of baseball. They're still using leather. You have to kill an animal for your leather glove. The ball is leather. It's got rubber bands on the inside. They spit. They use pine tar resin, and I'm thinking, was any of that ever considered modern? Because right now that stuff looks old.
Yes, I think it's tremendously modern, right? The baseball bat has gone through multiple evolutions in time, from very simple
2x4.
Wood sticks.
Just get your 2x4 out.
So now you go to a place like Louisville Slugger. The engineering of the bats is very, very serious and thoughtful about the woods that are being chosen, how and where the wood is being cultivated. It is deeply technoscientific, as well as the ball, right? The ball has gone through multiple iterations, even down to the more recent instances of people talking about the baseball being juiced. And a lot of some more recent research has been studying the seams of the ball. And the question is, how the ball has changed and evolved over time is part of this continuous technoscientific evolution. you can't get the same leather that the ball was made out of 100 years ago because we've killed all those cows. And eventually,
but cows today are fatter, so maybe their skin is thinner. I don't know.
True, but tanning is a kind of old school technology, right? Late 19th, early 20th century, and a lot of the materials are still being tanned by the same few factories in the United States. Horween is one factory that tans for the NBA balls and also NFL footballs. So they're trying to maintain the continuity, but I would say very deeply technological in science.
It's weird. I know Chuck and Gary have questions, but it's weird to think that they want to be consistent with the past. But for example, they've changed the athlete's diet. They've changed their exercise regimen. They've changed the medicine surrounding it. Oh, but the ball has to be exactly the same, and this has to be exactly the same. So it's weird that the body is allowed to change, but the other stuff related to the sport isn't. To me, that looks very inconsistent.
I agree with you completely. It's totally inconsistent. The ball is not the same as it was 100 years ago.
Right.
The bat is not the same.
Right. Right. In fact, the mound in a baseball field is 6 inches lower than it used to be, right? I mean, they're changing stuff, so don't pretend like it's all pure, right? So, Chuck, what do you got?
Speaking of things changing, is there a technological advancement that can be too much, too soon, too fast, so that you have altered the game in such a way where the spirit of the competition is compromised?
Ooh. That sounds like you rehearsed that question.
No, I just thought
that sounds like it's show all work. Yes, compare and contrast.
No, that popped into my head.
He's going to use that question on the next exam he administers. You know it.
But no, because you guys were just talking about everything has changed. Yeah. But those changes are kind of gradual. So can it happen in such a way that you look at it and you say, nope, that's too advanced. That's too much changed. And you're changing the spirit of the competition itself.
Yes, absolutely. I mean, there have been multiple instances where the technology has changed the understanding of the sport. One of the biggest examples in recent past is the Speedo Laser Racer swimsuit, which changed the nature of the competition from individual bodies to the question about who is using which existing suit, who is using which new technology. So you have world championships in, say, 2009, where 40 plus world records were broken in one world championship.
Oh.
And it all has to do with the suit and the technology.
Well, so it's no longer about the athlete.
No, it's about the suit. So the narrative of the sport is like traditionally, part of what makes baseball so unique is they're saying, well, it's such a simple sport. It's just the ball and the bat, and it's about individual athletic brilliance. And historically, the same thing would go for swimming. It's just athletic talent. However, all of a sudden it transitioned from which athlete, how much time they spent in the pool, how much training they had done, to who was wearing the fastest suit. And sport governing bodies who are selling athletic performance and not swimsuits had to change that. So by 2010, they banned all of these polyurethane, super high performance suits.
I feel like old school, like I'm the grandpa on the porch in the rocking chair when I say, back in my day, Mark Spitz had a hairy chest, had a mustache, and my boy still won all those gold medals in 1976.
He actually swam in a sweater.
A sweater.
He was wearing a cardigan while he was swimming and still broke world records.
In the snow. Yeah, in fact, it was ice. He swam in the ice.
There are some very interesting instances where the athletes actually revolted. So most recently, NBA, a handful of years ago, introduced synthetic basketball to the NBA. And a handful of players, primarily led by Steve Nash and others, said that they had no part in changing the ball. It was different. It bounced different. It felt different. And eventually, the NBA Players Association was able to force the NBA to go back to its traditional leather ball. And the idea is that the Spalding and the NBA was trying to produce a modern techno-scientific ball, one that was grippier when it was wet, one that performed better. It was more consistent, right? Because if you're thinking about leather on balls, they come from different animals, different cows. The consistency is suspect. So you could create this new technology that allowed you to have really similar balls from game to game to arena to state. But the players said this ball was different than they were used to playing with. It changed the game in a substantive way, and they wanted the old leather ball back.
So they should use free range cows for their leather balls. So that they're happy cows. Those.
All right. Okay, Professor. If I look back, and I'm using the word intentionally, I find one thing that seems to have changed sport, no matter which event it is, more than anything else, and it's cameras. I mean, am I the only person who thinks cameras, or has it had such a profound effect on the way we are engaged in sport now?
Well, we the viewer or the athlete?
We the viewer, the athlete.
Oh, sure,
coaches,
of course the viewer. But how is the athlete touched by a camera?
Well, some had to be using it because we have footage of games from way back before there was television. Somebody was filming that for some reason.
Yeah. I mean, Lombardi was using game footage to analyze opponents in the mid-'60s. And he would roll his defensive unit in or offensive unit in, sit them down. Now watch this. Now this is how this happens. Now, without sort of slow motion, without instant replay, without all of those clever things that came through, for me, this sport isn't as big. Football does not take off without massive TV audience and without the upgrading cameras. For me, it doesn't happen.
So you're saying Lombardi was just an ordinary coach, but he had really good technology. the camera, the footage.
That's you putting words in my mouth that I never said.
I like
it. He had an asymmetric advantage if he's using video or film and other people aren't. So So what do you say here, Professor?
Well, definitely. I mean, two most recent examples. I don't know, we're getting onto the world of cheating, but we think about the Houston Astros, more a little further back, 2007 with the New England Patriots and Spygate.
That's right.
So there have been cameras used to observe the opponent for multiple different times and for different agendas. And Lombardi is just one of many who have used cameras to observe the ways that people perform. Right? It's an old technique. It's espionage. You think about
espionage. That's what it is. Oh my gosh.
S-71 Blackbirds. It's an old war technique, and sport is driven by these metaphors of competition and warfare. It's about gathering data using a camera, which will give people a very strong visual representation of what's happening. So yeah, totally powerful.
I once visited the Seattle Seahawks training camp, and when they were in their they have a training dome, basically, like one of those inflatable things. And he wouldn't let me take pictures in there. They wouldn't want to show their moves.
Chance.
Yeah, not
he
a chance.
likes you. He doesn't love you.
Yeah. Yeah, no, that was, I'd not thought about that until that moment where he says, no, not in here. We're working on plays, and you get to see what the athletes are doing. So that's his polite way that's his strategic defense initiative, preventing me from possibly exploiting his secrets. So damn. So you're going with that war metaphor. That's good.
Well, I mean, a lot of coaches see it quite literally as a war for X amount of minutes or hours, and it's, hopefully there's no deaths or casualties. But to them, it is mano a mano. It is a war. I just look now, Professor. If I take my 200-inch TV screen in the ginormous man cave, and I want to watch pictures that aren't very good quality, I need myself a 5K picture. Therefore, I got to have 5K cameras. And all of a sudden, I have such a sharp image. Am I opening up then the route for artificial intelligence? Because back in a blurry day, artificial intelligence couldn't analyze as accurately, or have I just made
it didn't have the data? You mean it couldn't get the data? Yeah,
it couldn't get the data, couldn't get the sharp enough image. I mean, I think for golf, for tennis, for baseball, with spin rates, all those sort of different sports, with camera technology comes an advance in other ways technology is enabled.
Wait. It's not only the 5K. It would be, because you said spin rate, it's 5K plus a frame rate.
Right. Yes.
So that things aren't a blur, and then you can actually track this. So Rayvon, where does that fit in? Just high res data, time and spatial data.
it is totally where much I think there's a lot of potential within the context of sport, because now instead of using, say, Lombardi taking photographs, you can have that data coming into your home, and Gary can now be the next sabermetrics data analyst. And he's just sitting on his couch, slowing down the frame rate, doing his analysis on his own. So it opens up, in many ways, it potentially democratizes the use of data in certain ways that was not necessarily available. Because like Neil, you said you couldn't take photographs in the arena, but in many ways, you might not need to be in the arena anymore. You can just sit at home and download the data and use it how you see fit.
Mm-hmm. All right, well, we got to take a quick break. We're going to shift from cameras and the data it provides us so that we can gain an asymmetric advantage. We've got to use these war terms. Let's keep doing that if that's what this is. I'm going to see what more of high tech has influenced the sport when StarTalk continues. We're back, StarTalk Sports Edition. We're talking about game changers, and in this case, what role tech has played in this. And of course, we've got Professor Raymond Fouché. That's an E with an accent, in case you didn't know how to pronounce the trailing E. He's at Purdue University, who basically, literally, figuratively and literally wrote the book on this. And that book was titled The Game Changer, The Techno-Scientific Revolution in Sports. When was that published, Raymond?
2017.
2017, so it should still be out there. Excellent. And who published it?
Johns Hopkins University Press.
Good, so we'll give them a shout out there. Good, thanks for mentioning that. So with cameras are giving us sort of some people who use it cleverly an asymmetric advantage. If you connected the information the cameras obtain to computers and using that to analyze, so it's not just a human looking at it, we now feed it to computers. At what point did computers start mattering in sports, would you say?
I would say really when the computational power started to push forward in a big way, late 90s, early 2000s. And in many ways, I think a big marker of the combination of all these pieces is 2006 when we get the MIT Sloan conference on sports analytics. It's the one point where I think that's the culmination of the moment of everyone seeing the power the computation could have. But I think really it's late 90s, early 2000s when instead of having large scale computers, the personal computer could do a lot of the data crunching and data analytics. You didn't need to go to your local university and ask for supercomputing time to do some data analytics. And that's when it became a real powerful tool.
You know, interesting, this is a little bit off the subject, but I'm going to slip it in there because we were thinking warfare. So to design a fuselage of an airplane to be stealth requires very significant calculations so that any surface that reflects a radar signal towards it will not reflect it back towards the detector at all so that it doesn't show up. And in the 1970s and 80s, computing was so primitive that they could only solve the equations with straight lines. So the F-117 stealth fighter has these surfaces, flat surfaces on it, because that's the best they could do. They couldn't fit the spline, the continual spline solution to the shape of the fuselage. Once the computing power boosted into the 80s and into the 90s, then they could design the B-2 stealth bomber. And all the surfaces are curved on that in all places. So this is computing power having it totally affecting, of course, not only sports, but everything in our lives.
Yeah. No, I think that connection is deeply related because arguably, I think some of the people that are doing that high level computing, engineering are also interested in sports.
Does computing count because I remember there was a big deal in the US Open, tennis Open, where IBM was brought in to detect to see if the ball hit the line or didn't. And and it was like, wow, this is computing and it's this. And I remember the enthusiasm behind that. Not everyone embraced it, but with computers as judges, is this a thing? As referees?
Without a doubt. And we are here at this moment. And this is a huge controversy because we're asking the big question of do we want to eliminate humans and their, well, I'll just say idiosyncrasies,
right? Or their biases.
You can't kick dirt on the shoes of a computer because you're angry with the call.
No. So Major League Baseball has experimented already with in some of their minor leagues.
Strike zones.
With the strike zones.
Really? Oh.
Yeah.
Yes. And where you have a home plate official who has microphones in his or headphones in his ears, and the ball comes by and they call ball a strike. And so now, do you want your officials to be bystanders or just reporting out the information that's
I want a reporter, but I think
wait. Why do you want a reporter?
Because
what do you need him for? It's either is a strike or it isn't. At that point.
Officials are part of the game.
No, here's why you need them. You need them because there are things that happen at the plate that still require sportsmanship. There's certain conduct that needs to be monitored. There's also factors of cheating that could happen.
Program that into the AI and get rid of the umpire. That's the whole point of AI. It'll do what the humans do, but better. And this is computing power at its next extreme here, correct?
Yeah, but I think the limitations are that we, as the rules are written right now, they're not capable of enacting this clear specificity that the AIs can.
Right.
Because essentially the strike zone, halfway between the shoulder and the waist. That's the Major League Baseball's understanding of it.
But see, that's that. I don't want him there. I don't want the AI for that. Even though the AI from a camera angle might be able to determine that, I only want it for inside, outside, over the plate. That's all I want the AI for, because everything else is still subjective. There really isn't there's not an objective strike zone.
Okay, you're in the wrong place here. So you just program into the AI a subjectivity. So it gets 1 in 10 calls wrong. How about that? And you don't know which call that's going to be.
No.
We can now. In fact, you could have the record. You could preload the ball strike record of any ump you want, and it'll be them.
But here's the problem with that.
What?
Okay.
What?
I don't want a computer to be just as stupid as me.
Okay, stop.
I can't know. No.
Wait, Gary, you going to ask him about Moneyball and stuff? What?
Oh no, okay. Moneyball was pre-computer power. That was all done with sort of human brain, I think.
But it's still analytics. It's still analytics.
I mean, it is the birth of analytics in sport to another level, but it's still pre-computers. Now, what we've just discussed here has got me jumping even further forward. Professor, am I wrong here? Where normally the rules of the game, the rules of the sport, the laws that are engaged to play or execute the performance are written by humans. With the technology that we've just discussed with Chuck and Neil and yourself, are we not at the point where the technology is in advance of the rules and the rules have now got to play catch up? Are we in that zone already, or is that something in the next few years?
We're in that zone, and I think people are not very happy that we're in that zone. For instance, what is a catch in the NFL?
Right.
And it's possession.
Right.
Control. It's control.
Well, it's possession and control and a football move.
and so the question is, like, I'm on board with you, Neil. You can clearly program an AI to make that decision. But the problem is we haven't made that decision outside of the AI to even have that discussion.
Right.
So if we can't tell the AI what to do.
If you don't even know what it is you're saying it's doing.
Exactly.
Yeah. So, but I like the idea that technology is pushing us to have to make those decisions, because now, we live in a world where the AI can do it. And the only reason we don't have a clear understanding of what a catch is because we're not willing to make that decision. We're not being willing to lay that terminology down in text and say, we're doing this because the technology exists at this moment to make clear, accurate, definitive decisions.
Somebody's got to judge whether the person was in control of the ball to judge it to be a correct catch. And and that's not written down anywhere. It's just somebody's looking at it. They know it if they see it.
Yes, exactly. It's like that was control, that wasn't control, or he was bobbling. Some will say that the ball moving at all is a lack of control, whereas others will say it was moving while he had it trapped to his body, therefore he still had control.
Yeah, but did his knee hit the ground before that happened? Right.
Exactly.
Okay, I got another one for you. I think about this all the time. This is the first I've ever gone public on this. So what you can do is you have a pitcher, and you can get the statistics of the spread of where the ball is thrown to the catcher. Mm-hmm. Okay, and so you can look at the statistical likelihood that pitcher is going to throw outside of that zone. Okay, so if one of the pitches comes and floats up and damn near hits the batter in the head, you eject the pitcher if that's a 2 or 3 sigma throw. Whereas if the pitcher's just wild today, then the throw that kind of goes near the head, there's no intent there, because the pitcher's control has not demonstrated that could be intentional. Mm-hmm. So you can statistically judge whether the throw was at the person's head or not.
Yeah, but isn't chin music a part of the game?
Okay.
And then the fact is, you just have to know whether the pitcher and the hitter have got something going on historically, right? And he's likely to ding one off his helmet, and it's all going to break loose, and the bench is clear.
All right, how about this? Let me move this forward. My father used to run track, and he at the finish line, there would be people with stopwatches, and each person, it was their job. You would time the second place person, the third or the fourth, whichever. Okay, and then they come and compare all the stopwatches. All right. This involves human reaction time, all of this. That's all went to cameras. It's now digital. And in swimming, they do it to 100th of a second. Is there going to be a day where we're not really improving all that much, so we got to go down to like 10,000th of a second or 100,000th of a second? You could set a world record by being 100,000th of a second faster than the previous record?
Yeah, absolutely. I mean, we're already here because we can time well below the chosen level. And yes, hand timing has been problematic, and they've been slowly.
This is in swimming, hand timing. Yeah.
Across the sport, right? So, in the 1950s, they're saying hand timing was off by a quarter a second. By the 60s, they're saying roughly hand timing was off by about a 10th of a second. So people were getting better, but now timing is all fully automated. And we're at the point right now where we can time even more detailed than not. So, for instance, in the last handful of years, there's been a couple ties in World Cup skiing. However, they're timing down to, I think, the millionth of a second in World Cup skiing. So,
but they're not. I bet they're not tied to a millionth of a second. So they could have easily picked the winner there.
Exactly. So, but they don't want to, because I think the argument is that we don't believe that the infrastructure of sport is clear enough to time to that level. And you gave the instance of swimming. It's impossible to build a completely perfectly square swimming pool, right? Oh. It's pouring a big, massive concrete block.
Okay, there you go.
Your hair. I mean, my house isn't straight. How can you think about pouring this liquid substance and making it perfectly straight? So, in theory, what one lane is longer than another. And if we're starting to time down to the 10 millionth of a second, it may be that the pool is not square instead of someone swam fast.
Or you didn't arrive at your destination with the correct phasing of your stroke.
Exactly.
And you had to bring your helm on another swing, and then you just lost a quarter of a second right there. Okay, so so this happens in science all the time, where it's possible to have excess precision for the question that has been posed. And using that precision becomes completely misleading and, in fact, false.
Yes. Oh, wow.
That's a
sad
too much data.
state. That's a very sad state. It's like,
I'll give you an example. So in track and field, I think they still do this. It's not when your head crosses the front line. Mm-hmm. It's your chest.
Okay. Yeah. Which is that why everybody leans?
That's why they lean, right? Okay. It's your chest. Well, if you can measure this to a millionth of a second, that's the time between your shirts crossing the line and your flesh. Okay. but they're only measuring your shirt. So maybe people will wear like big bosoms or something.
I should have never. I mean, if only I didn't have these blasted man boobs.
No. I'm just agreeing with Raymond here that you end up measuring things that are not even what you're trying to measure. Oh, man.
And part of it is we don't have the rules to deal with that kind of accuracy.
That's it. So in the accuracy that we do have and that we're using right now, are there events, and I know if they are, they would be very infrequent, but in world-class events, do we ever have ties anymore? Do we ever have somebody coming in on the clock at the same exact time?
The answer is yes, but we can time it better and show that they're not at the same time, but then you're measuring other things at that point. This is the point I was trying to make. Chuck?
We have to have a winner.
No, I'm saying has there been instances where we've had ties? I mean,
yes, in the 100-meter dash.
Oh, okay.
And when you have a tie, two people stand on the podium at the number one spot. They omit the second spot, and then a person comes in third. So there's no silver medal given when that happens.
Okay,
that's how they do that.
I was just unaware if it had ever happened.
But that shouldn't happen any longer.
It wouldn't have to happen. But let's take a quick break and we'll come back.
Right.
We'll just digest all of this and shoot the shit with Rayvon, our professor at large, helping us unpack technology and sports when we return. We're back. StarTalk, Sports Edition. I got Professor Fouché from Purdue University, the Boilermakers, and that's a whole town full of engineers right there. So you've got just the expertise we need for this show. We're talking about game changers, athletes, but in this case, we're talking about technology. And so we've got in recent past some examples of damn near geriatric, highly performing athletes. Like
Name names.
So what do we have? We have how old is LeBron? LeBron is like 36.
Yeah.
Okay, that's a foot in the grave right there. And Tom Brady was 43 in the Super Bowl.
He died 3 years ago and didn't even know it.
So, but they're at their height. They're not just put out to pasture and we keep them just because they sell tickets. They're actually performing at the top of their
Brees
game.
Is another one.
Yeah. So tell me about technology and health and surgery and all the rest of that. There'd be medical technology, of course.
I think clearly we're at the front edge of what we can do physiologically with athletes. With the amount of, at least football players, right? And you mentioned two examples, LeBron. LeBron is on pace to have the most mileage on his legs of any NBA player in history of the game. Similarly, Tom Brady playing at his level until 43.
Just remind me, LeBron came right out of high school, right?
Yeah, correct.
Right. Okay.
And so obviously there's a whole infrastructure that's allowing these athletes to perform longer and at the highest level. And it's not just a crisp bowl of Wheaties every morning that's allowing them to perform at that high level, right? There's a whole infrastructure of health professionals, bodily treatments, scientific and technological training methods that allow these athletes to continue to play long.
Diet is in there too. Yes. Yeah, all of this. Mm-hmm. And so, all right. So let's unpack the 900-pound elephant in the room. If technology helps you win, if you have the technology and other people don't, what's the difference between that and cheating?
It's all about perspective, right? Of all kinds of things. So from my perspective, sport is not about equality. Sport is about maintaining a competitive advantage for as long as possible, legally or illegally. So I think there's a gray space when we have the conversation about cheating. And I would say it's only cheating until it's been officially banned within a sporting governing body or sporting environment. And
so Fosbury didn't cheat when he jumped backwards over the bar with the Fosbury flop.
He did not.
He was not cheating.
Which is smarter, Neil. I mean, let's. I mean, all right. I'll use my own body because I had knee ligament reconstruction. Right now, the whole idea of that is it is stronger after surgery than before I damaged it.
Oh.
Now, am coming
We can
back,
rebuild him. We can.
but am I now doped? Have I now body doped by having surgery that's actually made my knee ligament stronger? I mean,
That's like the Tommy John surgery in baseball.
Correct. So this is the point the professor is making, I think. Until it's made illegal, it's okay. But is it in the spirit of things cheating?
I would say it's completely within the spirit of sport.
Right.
Because the spirit of sport is about winning. And I think that's what makes the technology and science so powerful and so awesome at the moment.
No, in elementary school, it's about participating. Okay, just to make you.
Okay. Thank you.
just let's get that straight.
I think we're all past elementary school. So
you get your participation trophy.
Speak for yourself.
Oh, Chuck, I like that your participation trophy on your shelf there, Chuck.
Exactly.
Yeah.
No, so I mean, technology is the place where you can gain and acquire the biggest competitive advantage. And so many of the technologies, computational processes, health mechanisms, the governing bodies of the sport aren't looking at and aren't thinking about. So therefore, it's kind of an open world for people to experiment and see what the limits are and how they can improve their bodies.
Wait, Gary, is that a real thing from my notes here? Like ghost pacers from an augmented reality glasses you wear? Is that real?
By the way, sir, yes.
Damn.
I know. So this thing is now otherworldly. So imagine I gave you a pair of, look like a normal pair of sunglasses. You put them on, you're going to go run around a track. Then all of a sudden, this augmented reality appears in front of you and you can't catch it because it's been set at a certain pace. Imagine you're an elite athlete. We talked about it in a recent show, right? About the marathon breaking 2 hours, right? Kipchoge. Imagine he was training with one of these that just made him run faster and faster and faster until he gets himself under 2 hours. This is the sort of technological advancement we're finding ourselves with outside of someone's got to run in front of you, burn themselves out, and then someone else has got to come in. So you go through half a dozen pacemakers during a marathon.
Right.
Nope. This thing's going to run.
But that really isn't very different from the way anyone trains now. I mean, that's the same as a sparring partner. The better your sparring partner, the better boxer you will be. Or
wait, if a sparring partner kicked your ass every day, then you should be the sparring partner.
That's I was going to say. Or you're just not going to be boxing, you know. But you don't want to spar with somebody who can't box very well because that doesn't help you at all. So, you know, the pacing, I think pacing is different.
Plus, I wouldn't want to not be able to catch the augmented reality. You set it up so that I catch it right at the finish line, and then I have some sense of triumph.
So, okay, I was about to say there is. How about what's the experiment where they took mice or a rat and they put it and they let it swim halfway and then they wouldn't allow it to ever reach the edge, and so it ended up giving up and drowning. I mean, can you break somebody's spirit by training them to a place where they never receive a reward?
You probably can, Chuck, but I think it's now the technology has to be managed because otherwise, as you've just described, is a destructive.
Wait, so Rayvon, what my co-hosts are telling us here is that athletes, they need a little tasty tidbit every time they achieve something, like they feed the dolphin in the swimming pool.
So you can't keep the carrot out there forever. You got
to toss them a fish. Toss them a fish when they get it right. But where's this headed? Where are we going 10 years from now? What's going on?
I mean, I think this is getting back to what Chuck was saying about and just pushing a limit, right? So the outer edge is this whole world of neural stimulation, right? So
yeah, right.
The idea is that athletes, the brain is the limiting factor within athletic ability and competition. Mm-hmm. So in a sense, your brain breaks down.
I was going to tweet that about a week ago. I was saving for a good moment. It's that very thing, right? Elite athletes are limited not by their bodies, but by their brains, by their minds.
Yeah. Right. So some people have been saying, research is saying that, well, what's happening is you're getting central fatigue, and that all of a sudden you're getting weaker signals from your body, from your brain to your muscles. So therefore, you work on a series of neurostimulations, create more plasticity within the brain, and allow and train yourself to push farther and deeper into the pain zone and allow your body to produce stronger signals to your muscles.
So you'll be ignoring your evolutionary signs to stop.
Yes.
Or even overriding them.
Overriding. Yes. That's a better term.
Yes. And so the idea is to
okay, but we're all going to be like the dude who ran from Marathon to Athens and to report on the battle and then just drop dead. That's what's going to happen. If you don't drop dead at the finish line, then you didn't give all the energy you could have. Is that what you're telling us?
That's where the goal is, right?
Okay. No, you're not supposed to agree with that sentence.
No. Well, this has been something with LeBron being dead and Brady. So
I didn't say that for you to agree with the sentence. Okay.
No, I love it. It's the Kellen Winslow. It's the Kellen Winslow effect. Like if they don't carry you off the field, then you didn't do your job.
Don't leave anything on the field.
So the thing, I mean, we've had this thought process in sport and in training for decades and decades. You train harder than you compete. So as when you compete, you're not at the edge of your envelope. And Chuck and I had a discussion.
Wait. I can tell you what that makes sense to hear it, but it's not true. Why? Because no one breaks world records while they're training.
I know, but once you get into the element of competition, other stuff kicks in and you push. So you know what you need to do to win. And so you train beyond that. So if anything ever comes along, you're always working within comfort and without the stress. So you've got that wriggle room to push further onwards to get to be even better.
But I'm not convinced people aren't breaking world records in training. They're just not organized and have the record keeping. I think people are going extremely fast and powerful in training. They're just not officially sanctioned, right? When we think about world records, official sanctioning events.
The absence of data on that, yes. Okay, I'm with you.
Nothing would piss me off more than to break a world record while I was practicing.
And while nobody was looking.
And nobody was there.
Well, that won't happen now, Chuck, because everything is filmed. Absolutely everything is filmed. And we go back to the cameras where the super high speed cameras with tens of thousands frames a second, and there's nothing goes past anybody anymore. So it will be captured. I mean, look at our dear friend Sasha Cohen. She produced, was it a quadruple Salchow?
The quad, yes.
In a warm-up routine rather than in competition, and she landed it. It's on film, so therefore she owns one.
Right.
So credit to her.
So let me ask you this then. Speaking of that, because she never did it in competition, not to disparage her in any way, but the fact is she didn't. Is there any technology that can monitor and help an athlete kind of stay in the zone so that when the time comes, they're just popping in the zone right when they need to be?
Yeah, so I think this is one of the leading edges of where we are as well. There are companies that are in the process of trying to track biometric data and figure out peak performance. So generally, a lot of these organizations and companies and research labs have gotten very, very good at tracking a series of biometric data points and being able to determine if you'll be at your highest level of peak performance. So that's the part they're really good at. However, the part where it breaks down is the less biometrically data related events. So you could be ready to perform at your highest level, but you got in an argument with your mother, your girlfriend broke up with you, you got in a car accident, all of these other social things that intervene in one's life may derail you.
No, Rayvon, you just put in brain implants that'll rub that out. Oh. I mean, let's go 10 years into the future. So it's just your brain.
So therefore, then we'll just go robotic all the way.
Yeah,
right. In the bodies. Because it's the bodies.
You have your match and you go home. You're like, who are you? I'm
Raymond. I wish I had a rebuttal to that sentence, and I don't. Yeah. You're right. If once you start tickling and twitching brain cells, interrupting or enhancing neurochemical synapses you're a machine at that point.
All right. So now let me ask you this. Speaking of machines, is there or will there be an acceptable time for implantation to be a part of any sport?
Implantation of what?
Oh, of anything, whether it's not just sensors, but augmentation. So the implantation actually heightens your performance.
Okay,
so
wait. Suppose
so we're talking prosthetics thing.
Wait, suppose I have a bad heart and I get a pacemaker. Okay, and now I'm a senior running in a 65 and older race. Did the pacemaker prevent me from dying? Yes. Did it make me win the race? I don't know. But there's a lot of stuff we can put in our bodies, and it already is put in our bodies. So Rayvon, where does that sit going forward?
I think we're already at the point where generally I think people are going to get more comfortable with it. Because I think we're understanding as a society that the world in which we live is techno-scientifically driven and mediates all things that we live with. And we're getting to the point where we're going to have to give up on this illusion that sport is all about the human body and just generic performance. The technology is here. If we can talk about the pacemaker, we can talk about all these kind of technological innovations. And eventually it's going to come to the point where we're going to be more interested in the great athletic performances and what the technology can bring than I think old school representations or ideas of what an athlete should be.
Wow.
Athletes go through surgical procedures, right? Kevin Durant, he's back playing, and that's pretty amazing.
Wait, what happened with him? Remind me. This is Kevin Durant, the basketball player.
Yeah.
So multiple injuries. He's gone through a series of injuries. Some gruesome ankle, feet,
calf
injuries. And I don't even know the extent of the bodily injuries, but an injury enough that allowed him, he had to sit out a whole season.
Right.
And so choose him or any other athletes who are sitting out long periods of time. And they're getting back because there's a massive amount of techno-scientific research to allow themselves to retrain their bodies.
That's not why they're getting back. They're getting back because they make it's money. That's why. I'm not retiring your ass. You get back on that court. I paid that for that contract.
True, but I mean, the only way they get back is there's
got to be something to make it happen. Yeah.
Of scientific and technological innovation going forward, and so I think we're getting to the point where if athletes are going to get injured, are we willing to say, well, maybe we should implant certain things, reconfigure their bodies, because we would like to see Tom Brady play another decade.
Wow.
And if
some of us would.
Yeah.
Some of us.
The only way I'd like to see him play another day is if he were wearing an Eagles uniform. Other than that.
So, I mean, Professor, are you actually saying that we're going to see some crusty old 40-somethings performing at the very top of Major League Baseball, NFL, NBA? Well, baseball maybe still, but are we going to see more dynamic sports populated by older athletes?
I think so.
Okay, I have to modify that. I think where pure skill matters, yes, but where physicality, no.
Right.
Yeah. So Brady is not the wide receiver at 43.
No.
Okay, so that's the difference.
Right
here.
Yeah. And his offensive line becomes way more important than it ever has.
Yeah, exactly. Because if anybody gets through, that's the end of Tom Brady.
Right. Exactly.
Yeah. You don't want to see that.
So, guys, we got to bring this to a close. Rayvon, it sounds like you're all in on this technology thing. I don't want to put words in your mouth, but it sounded like you're ready to take this wherever it can go.
I wouldn't say I'm ready to take it wherever it go, but I think we as a society are getting to the point where we are interested in seeing what technology can bring to the human body and athletic performance. And I think the next steps are really right around the corner.
In our lifetimes, you're saying?
Yes, definitely in our lifetime.
Okay. All right, dude. Well, this has been fascinating, and I'm sure we only just began to plumb the depths of this topic. All right, guys, we got to call it there. So thank you, Professor, for joining us for this. And guys, Gary, Chuck, always good to have you.
Thank you.
As co-host. This has been StarTalk, Sports Edition, Game Changers. I'm Neil deGrasse Tyson, your personal astrophysicist, occasionally posing as an ex-athlete for these shows. I hope to see you next time. As always, keep looking up.